Of time, we're gonna move hard and fast now for the next few stops here. So this is the ashy upper part of Ignimbrite A. Ignimbrite A is Miocene, 13.63 million years old, and we've seen the thick fiamme down there in the valley, and now we have the ashy part. That's the kind of dust and ash settling out towards the end. It's highly oxidized here, it's reddish, the grain size is much finer. And then we have this material here. This is clay, dominantly clay with some lisics in there, but this used to be a vitrophyre. We've seen vitrophyres at P1, the glassy material, but glass, as we discussed, is notoriously unstable at surface conditions. So if you have enough water, and look, we're just very close to the coast, there is enough water here, then this stuff will convert into clay, this glassy stuff, very swiftly. And this is what we see here. So this was the vitrophyre. It still has the stratigraphic position of the vitrophyre, but of course there is no glass left here at this particular location. But we have a new Ignimbrite coming in here. This is a lot more green, it's a lot more fine grained, and it has almost no crystals. That's the characteristic of Ignimbrite B. And it's very densely welded. So I'd like you guys to get your eyes in, spread out along here a little bit, and have a little look. Have a look whether you see crystals, and also note how densely welded it is. And here we have loads of these lithic clasts again, these compacted solid materials that were caught up in the eruption material, and they are kind of widespread here, implying that this was the part that was most heavily compacted. This is the lower part of the Ignimbrite. So compaction is of course weight dependent, so the more weight you put on top, the more the compaction will be, and therefore it will be strongest in the lowest part. This is also where the heat is most efficiently retained, and that means this is where the deformation can still be achieved after the material was deposited, provided it was hot enough to start with, which it was in this particular case. So you need to be above glass transition, so that's about 550 for this type of material. So these must have retained temperature of on the order of maybe 600 degrees or above after they were deposited. And later on I'll show you a few outcrops where we can even demonstrate that the material was still flowing after it was deposited, and that means it was pretty hot in order to do so. Okay guys, get your hand lenses out, have a little look a little bit over there, and let's give us 5 minutes and then we move on to the next stop.